Okay, hi, welcome back. In our last maths video, we learnt how you expand polynomials. And the example we showed was this one here, where we expanded x plus 2 times x minus 3 times 2x plus 1. And we got this result here, which is a cubic as a 3 as the highest order term. Now what we would really like to know, however, is how could you go backwards? What if you're given 2x cubed minus x squared minus 13x minus 6, and what if that was said to equal 0 and the question was solve it? What values of x give 0? In other words, find the x-intercepts. Well, what you'd have to do is you'd have to go from that backwards to this, and then use the null factor law. So you can use the null factor law to say that, well, the answers must be x is minus 2, or x could be plus 3, or from this one, x could be minus a half. So those are our three solutions based on this. But the difficult thing, of course, is actually doing this backward step, doing this factorization. And that's what we need to think about now. Now, before I go on, I just want you to consider the fact that suppose if this was not a cubic, if it was in fact just a quadratic, if it was just, say, x squared plus 6x minus 2, you would know, because it's quadratic, you would know that the answer would be something along these lines. It would have two sets of brackets that you would factorize it into, and you would know how to do that factorization using completing the square and then difference of perfect squares, as I've shown you in the other videos. So if you can somehow change this, you remember when we expanded this, we went through a step where we had two brackets. There's a two bracket step where there were sort of 3 terms in one and 2 terms in the other, and then so we first went from this to this, and then we expanded out. So similarly, you could go from this first to this halfway step, and then change this set here with the 3 things, because that will be a quadratic, into the 2 brackets. So this big one here will become 2 sets of brackets, and then this one will drop down and become your third, and then you'll have it in the right form. Okay, so that's sort of our overarching aim, to solve this by first getting into this stage where we've got a quadratic here, so something with some sort of x squared term going on, a quadratic and just a linear thing here with an x, and then something where we've got 3 x's, and they may have coefficients, or there may be something out the front even, but the form is the same with these 3 brackets here. So that's our overall aim, and the way we're going to achieve this is to be able to take this equation and divide it by something, and whatever we divide it by is going to be this thing here, because you notice that well, dividing is the opposite of timesing. So if we get to go from here to that, we multiply that bracket by that bracket. So to go from this the other way, obviously the thing we do is divide, as division is the opposite to times. So to go from here to here, we're going to divide. So we need to divide by like x, say x minus some value here. So let's say x minus a needs to be divided out from this, and then that's how you get to this step. So this video, the remainder of this video is all going to be about dividing polynomials. Dividing polynomials is what we're looking at. And unfortunately for you, the technique is the same as your normal dividing numbers technique for long division, which I imagine very few of you can remember. So let's do a quick example. Let's say we were doing 172 divided by 13. First, you'd need to set this up. So we've got 172, which is our dividend, and we're dividing by 13, our divisor, and we're going to get an answer which is our quotient. Okay, so first we go, how many 13s do we have in 1? Obviously there are 0 13s in 1, so put a big stinking 0 there, but because it's a 0, let's not bother. So then we look at the next 2 digits. How many 13s are there in 17? Obviously there's 1. There's 1 13 in 17. Okay, so then we go 1 times 13, gives us 13. And then we do 17 minus 13 to say 4. So what that means is there is 1 13 in 17 with 4 left over, 4 remainder here. So now we'll drop down our next digit, which is our 2. So I've got 42, and we're going to ask the question, how many 13s are there in 42? Well, 1 13 is 13, 2 13s is 26, 3 13s is 39, 4 13s is 52. So evidently the answer, this one's too big, so there's 3 of them. So there's 3 of them. So now we'll do our 3 times 13 was 39. And we'll see how many left over. So 13 goes into 42 3 times with how many left over? 42 minus 39 is, of course, 3. So there's 3 left over. So, in answer to our question, 172 divided by 13 equals 13 with 3 left over. So it's because it's 3 left over, it's 3 and 3 13ths. 3 and 3 13ths is what we have because there's 3 left over. Or another way to represent this would be to say that 172 equals 13 times 13, 13 times 13, plus the extra 3 that we had. So 172 is 13 times 13 plus the 3 that we had. Okay, so that's the method we use with numbers. And we can do the exact same method, but using algebraic expressions or polynomials in particular. So let's start off and say that we want to, what we want to be doing maybe will be, let's do x squared plus 7x plus 11 divided by x minus 2. Okay, so first thing we need to set it up, and when you do this, do not be afraid to waste lots of paper. X squared plus 7x plus 11, so that goes here where our 172 went before. And dividing by x minus 2. Okay, so it's a similar thing going on. So we only need to really look at the x for now and go, how many x's or x minus 2's are there in x squared? Well, there's x of them with x now multiplied by this, so x times this stuff is x squared minus 2x. So that's what we have left over, if you like. So here 13 went into 17, 13 one time with 4 left over. Similarly here, x minus 2 goes into x squared x times with what we need to do a subtraction here. So x squared times minus x squared is 0. 7x minus negative 2x is 9x. So we have 9x left over. And we'll drop down our plus 11. So, how many x minus 2's are there in 9x plus 11? Well, there are going to be 9. Now 9 times x minus 2 is 9x minus 18. Do our subtraction here. 11 take away minus 18 is 29. So there we go, we've got a remainder of 29, and let's write this in our two different ways. So the answer to our initial problem is x plus 9. So our answer is x plus 9 plus a remainder of 29 over x plus 9. So 29x plus 9ths. So that's presenting our answer in this way. Or you can write it in this second way if you really want and say that x squared plus 7x plus 11 equals x minus 2 multiplied by x plus 9 with plus a remainder of 29. So we can write a general sort of expression for this thing here by saying any polynomial p with respect to x, you can divide it by x minus some number a, times whatever your quotient is, so qx. So if you like, that's quotient is sort of like the answer to a division. So times q of x plus some remainder with respect to x. Plus some remainder here. Now we can be a little bit clever with this. This is sort of delving into things that are coming up. I want you really to focus on just this division part, but since we've made it this far, I just want to point out what happens if we put in, polynomial, if we put in a for our x. Let's have a look. You get a minus a. So remember, a is whatever the number this is. So in this example, a would be 2. So here, a would be 2. Alright, so if we put in a, it's x minus a, which is a minus a times q of a plus some sort of remainder with respect to a. Now here we've got a minus a. A minus a is 0. So because that's 0, this entire term here all goes away and we just have the remainder. So we have, if we put a into our polynomial, you get the remainder. Whatever the remainder is will be whatever you put in for a here. Or if you evaluate this at a, you get the remainder. So let's put here in this example, a is 2. Here it is, a is 2. So if we put 2 in to our polynomial, this polynomial here, let's see what happens. Let me just use this space here. So I'm putting 2 in for x here. I'm going 2 squared plus 7 times 2 plus 11. 2 squared is 4. 7 times 2 is 14 plus 11. 4 plus 14 is 18 plus 11. 18 plus 11 is 29. And look at that, 29 is our remainder. So the remainder is 29 because we put a in for x, getting 29. So there's an extra bit of a shortcut, but of course this remainder theorem does not tell you, it doesn't tell you what the answer is, this answer. It will tell you this oh, hang on. I've made a boo-boo, this bit here. 29 and x minus 2. Oh dear. Sorry for everyone watching at home, I've just realised that I made this bit of an error. X plus 9 plus 29, x minus 2ths is this error. I will hopefully remember to edit this video and fix that up later on. But anyway, this remainder theorem does not tell you the answer, this answer here, x plus 9. Just made that a giant mess also. So keep that in mind and be wary of that. Okay, so that's all the content for this video, but I'm going to do one more example just in case anyone feels like they need one extra example. So stick with us if you want to see one more example. Okay, might do this example here where we have 2x cubed minus 15x squared plus 34x minus 13, and I'm going to divide that by 2x minus 7. Okay, so first thing I need to do is set this up in the right way. So 2x cubed minus 15x squared plus 34x minus 13, and I'm dividing that by 2x minus 7. Okay, so how many 2x minus 7s are there in 2x cubed? Well, there is x squared of them. Now x squared multiplied by this, 2x cubed minus 7x squared. Now, do a subtraction here. 2x cubed minus 2x cubed, that's 0 there. Now, minus 15x squared, take away minus 7x squared, so it's sort of like a plus, if you like, becomes negative 8x squared. Now, drop down our next term, which is plus 34x. Okay, next term. How many 2x minus 7s are there in minus 8x squared plus 34x? Well, there is minus 4x of them. The reason I know this is because minus 4x times 2x gives negative 8x squared. Negative 8x squared. Minus 4x times minus 7 gives a positive 28x. Do the subtraction again. 0 once again here. 34x minus 28x. 6x. Drop down our last term, minus 13. How many 2x minus 7s are there in 6x minus 13? There is 3 of them. 3 times 2x minus 7 is 6x. 3 times minus 7 gives me minus 21. Do a subtraction again. 0 here. Minus 13 minus a negative 21. It's like minus 13 plus 21, which gives 8. So, the overall answer to our initial problem is this, is x squared minus 4x plus 3 plus 8 over 2x minus 7. 8 over 2x minus 7. Or, once again, we have our second option of how to write this, of 2x cubed minus 15x squared plus 34x minus 13 equals our 2x minus 7 multiplied by our answer, x squared minus 4x plus 3 plus our remainder of 8. There we go, our remainder of 8. Fantastic. So I think I will just leave that video there. Hope you had a great time. See you in class.